Hello students, today I am going to deliver a lecture on the topic of clustering indexing. Students, indexing technique I have already explained in my previous lecture where I have described that the indexed file can reduce the number of accesses whenever we do access a record. Okay. So here in that case of clustering indexing, we always do search on the basis of non-key attribute. Okay. So a non-key attribute is that which is repeatable in tuples of a relational table. So the search key will always be a non-key attribute here. Okay. And in record file, the records will always be ordered on the basis of non-search key. Okay, where the records will always be placed where the records having the same non-attribute value will always be placed one after the another in consecutive manner. Due to this, the records having the same non-key attribute value will be present in a same block. There will be a high probability that the records having the same non-key attribute value will be present in the same block. So since the record file is in an ordered, therefore we use here sparse indexing. As I have already discussed in lecture of sparse and dense indexing, that whenever we have a sorted or we can say ordered file, sorted or the ordered file, then we can use sparse indexing. Sparse indexing means that correspond to a set of records, there will be a single entry in the index file. As you can see here, the index entry having the search key value 1 is referring the first block, the first record of the first block. Because the record having the non-key attribute value of 1 is present in the first block. Similarly, in the second entry of the index file, having the non-key attribute value 2 is pointing to the base address of the first record of the first block. Because records of non-key attribute value 2 are present in the first block. That is why the second index entry also pointing to the base address of the first block. Means that any index entry will always be, every index entry will always be point to the base address of the block, and the block must having the record having that non-key attribute value. As you can see here, the third index entry is pointing to the base address of the second block, because the second block is having a record having the non-key attribute value 3. Similarly, the index entry 4 is pointing to the base address of second block, because the second block is having records, having 4 records having the non-key attribute value 4. So in clustered indexing, we use the sparse indexing, where we also call it a dense indexing, because here every non-primary key attribute value is present in the index file. You can see here index entry, the search key value 1, 2, 3, 4, all are present in the index file. And the dash indexing says indexing is a dash indexing when every search key value is present in the index file. That is why it is an example of both sparse and the dense indexing. So let's discuss the access time of the cluster indexing. So whenever we need to access a record, so firstly we will refer the index file. Since the index file is ordered, we all know index file always be in a sorted, will always be a sorted file. So that is why we can apply here the binary search. And if the index file is having m blocks, then the number of access in the burst time will be equal to the log m by the help of binary search, right? So in the order of log n, we can access the desired entry, index entry, and through a pointer we can reach to a block which is desired, and that block we will access, and then that block we will access. Means the total access time will be equal to log n plus 1, log n for to get the index entry and plus 1 to get the block in which the record is present. So that's all about the clustered indexing. And in the next lecture I will discuss the secondary indexing. Thank you.